Okay, here's number 4b on 13.3. We need to find the unit tangent, unit normal vectors of r of t equals e to the negative ti plus e to the tj minus square root 2 times t k. To find the unit tangent vector, we need to find r prime. So r prime of t is equal to negative e to the negative t I plus e to the t j minus root 2 k. We also need the magnitude of r prime. So the magnitude of r prime is equal to e to the, well, the square root of e to the negative 2t plus e to the 2t plus 2. Now if you rearrange this as e to the 2t plus 2 plus 1 over e to the 2t, and think about it, you'll see that you can factor it as the square root, at least factor the radicand, as e to the t plus 1 over e to the t, quantity squared, like that. And if you take the square root of that, you just have e to the t plus 1 over e to the t. Combine these guys together, and you get e to the 2t plus 1 divided by e to the t. So that if you want to find the unit tangent vector, you could take the reciprocal of this. So t of t equals e to the t divided by e to the 2t plus 1 times r prime, which was negative e to the negative ti plus e to the t j minus square root of 2 k. And then if you distribute e to the t, you get 1 over e to the 2t plus 1 times just negative I plus e to the 2t j minus square root of 2 e to the t k. We've already found t of t. Now we need to find n of t, which is t prime divided by magnitude of t prime. Since t is a scalar function times a vector function, we're going to apply the product rule. I'll take the derivative of the first function, this guy up here, which turns out to be negative 2e to the 2t divided by e to the 2t plus 1 quantity squared, time function, which is negative I plus e to the 2tj minus root 2 e to the t k plus the original scalar function, 1 divided by e to the 2t plus 1 to 2e to the 2tj minus root 2 e to the t k. So there it all is. The next step, I will factor out e to the 2t plus 1 quantity squared from both denominators here and here. So that on the outside I'll have 1 divided by e to the 2t plus 1 quantity squared. On the inside I'll have a negative 2 e to the 2t times negative I plus e to the 2tj minus root 2 e to the t k. And then from this, what will be left is e to the 2t plus 1 times the vector e to the 2tj minus root 2 e to the t k. So that when the smoke clears, that's what I have. Okay. Close bracket. Now at this point, the idea is to multiply this guy out, and combine the like I, j's, and k's. And if you do that correctly, you'll end up with this. 1 divided by e to the 2t plus 1 quantity squared times 2e to the 2ti plus 2e to the 2tj plus square root 2 e to the t times e to the 2t minus 1 k. It'll look like that from a bird's eye view. Now we need the magnitude of t prime of t so that we can finish finding n of t. So, okay, I'm going to find magnitude of t prime of t. Well, I can just leave the scalar function on the outside. Write it as 1 divided by e to the 2t plus 1 squared. And then concentrate on this vector right here. Okay. The magnitude of that vector is the square root of 4e to the 4t plus 4e to the 4t plus 2e to the 2t. I'm squaring this factor, and I'm going to square this factor as well. So that's e to the 4t minus 2e to the 2t plus 1. Like that. Now, if I go ahead and rewrite the function on the outside, and I, on the inside, factor out 2e to the 2t and combine these two terms, then I'm left with 4e to the 2t plus e to the 4t minus 2e to the 2t plus 1. Like so. And then if I combine like terms, I'll be left with, underneath the radical, 2e to the 2t. I'm going to write it like this: e to the 4t plus 2e to the 2t, combining this guy and this guy, plus 1. And then, so here's what I have. And then the radical, well, okay, let me recopy the scalar function on the outside of the radical. And then inside the radical, this guy will factor to be e to the 2t plus 1 quantity squared. So that we have this. And then we can take the square root and get radical 2 e to the t times e to the 2t plus 1. So that, okay, this will cancel with this, and we'll be left with the magnitude of t prime as the square root of 2 e to the t divided by e to the 2t plus 1. Okay, we need to find n of t, which is t prime divided by magnitude of t prime. Way up here, we found t prime of t. There it is. And then down here, we found magnitude of t prime of t. There it is. So if I just take the reciprocal of the magnitude of t prime of t, which is e to the 2t plus 1 divided by square root of e to the t, and multiply it times t prime, which is this part, I'll have it. So there's what that looks like all together. And we will get some nice cancellation here. This guy will be gone. One of those factors will be gone. I think I'm going to leave this part on the outside and distribute the 1 over square root of 2 e to the t, so that I have on the outside 1 divided by e to the 2t plus 1 times 2 divided by radical 2 e to the ti plus 2 divided by radical 2 e to the tj plus just e to the 2t minus 1. Okay. And then if you rationalize 2 divided by radical 2, you do get something nicer. So I'll write that down. So on the outside, e to the 2t plus 1. On the inside, you'll get radical 2 e to the ti plus radical 2 e to the t j plus e to the 2t minus 1. Okay. So here's what it looks like. And that's it. So here's all the work that it took. Started way up here. And ended up down here. This is, what we just found is n of t. And that's the end of the last part, part 4.